Okay, YouTube, in this video we're going to continue to practice writing exponential growth and decay models and then using that information to make some predictions that we're interested in finding. And so let's go ahead and really quickly write out our growth model. Now when we talk about a growth model, this is an exponential function. So we would say that certainly this is something of the form f of x equals a times b to the x power here. But when we say a growth model, we often use f of x or y is equal to some a, which is our initial amount, times 1 plus r to the t, where our a value is our initial amount, what we're starting with. So we say initial amount. Okay. Our r value here is our rate of increase or decrease per time, or decrease. Okay. Up. We want an E there. And then we'd say that T is our time or some other variable there. We could definitely use X if we did not prefer to use the T there. But essentially this would be our growth model. In terms of our decay model, okay, a little bit different. Our decay model would certainly be not going up in value over time, but we'd say going down in value over time. So we say 1 minus that rate over time. This would be our decay model. And so really quickly, let's just make sure that our vocab is straightened out here. We'd say that this is our growth factor here. We say our growth factor is the amount we're increasing or decreasing by every time. And we say this is our decay factor. Okay, so in terms of writing models, this is kind of an important fact. The first and foremost thing we want to do when we come across a situation that we can model is write the model first and then use that model later to answer the other questions that we may be being asked. So when we look at this first example, it says the value of a new car purchased for $24,900 decreased by 12% per year. What we want to do is write an exponential decay model. So we know that we're going to be using this 1 minus r scheme here. But the decay model for the value of the car and use it to determine the approximate number of years after which this car will be worth half its purchase price. And so what we're going to do essentially is look at this as a situation where we would say, okay, well, in terms of our decay model, we would say that it'd have to be f of x, okay, equal to an initial amount times 1 minus our rate to the time. And so you can see that I've already placed an f of x and t here. The only two things I want to know are what are the initial amount and what are the rate. And so because we see that our initial amount, we're going to write this here, our a value is $24,900 and our rate here is 12%, which we're immediately going to convert to a decimal. We would end up with this right here, this expression. We would say that this would be 24,900 and this would be 0.12. Now I will say that in terms of model writing, it's entirely appropriate 24900 to go ahead and simplify what we have in parentheses here, and this would just come out to be 0.88 or over time. And so essentially what's happening is we're starting with this initial value of the car is 24,900, and every year it's only going to be worth 88% of what it was the year before. And that's because we're taking off this initial 12%. And so here is our model that we've written for this here. Now to answer our question, it says, use this model to determine the approximate number of years after which this car will be worth half of its purchase price. Remember that this initial y value here, or not the initial y value, but the y value right here, represents the amount of something, in this case the amount of dollars our car is worth, where t is time. Okay, so when we look at this and it says determine the approximate number of years, essentially what I want you to understand is what it's asking us for is to find the time. And it says when the car will be worth half of its purchase price. Now in terms of half of its purchase price, this is okay. We'll just go ahead and take a look at this here. We could say 24900 divided by 2. If we were to look at this here, this would be 12,450. And so essentially to look at what we're trying to figure out here, we would say, well, what I want to know is if the value of the car is 12,450 and we started with 24,900 at a decay rate, okay, decay factor of 88% over time, the real question becomes what's the time? And so again, here's the situation where I've said, okay, well, we haven't talked about logarithms yet. We haven't talked about how to solve for an exponent yet using logarithms to do so. Something like this is something we can certainly still answer on a calculator. And so again, what we're going to do is we're going to go put this model in for our calculator here. And I'm going to say 24,900, and this is going to be times 0.88 to the power of. Now we're going to have to use an x instead of a t, but one thing I also want to do is this. I want to change our window so that it reflects our situation. That is to say that if we were to look at this really over time, we say here's our time flowing here. We know that with a decay model, this is the value in dollars of our car. We're starting with something and then it's decreasing over time. So I know that its initial amount right here started at 24,900, and I know that also our time, probably maybe I want to go out like 20 years. So what we're going to do is we're going to go into our window setting here. We'll start with our x values. We'll say let's start with an x value of 0 times 0, and we'll say we'll go out 20 years later, and how about we go by 2's? And then on our y-axis here, our smallest y value will start at $0. We're never going to get down to a value of 0. But our y maximum, let's go up to, I suppose, 24,900. We'll go up to 25,000. And what we're going to do is we're going to go to this option that says y scale. And what that's going to allow us to do is to say we want to go by something other than ones. So if I'm going up to 25,000, I'm going to be inclined to go by probably like 5,000s to get a good guesstimate here. But when I hit graph, you can see that here is the value of the car over this 20-year period. We can see that it's definitely decreasing here. And so the real question became, okay, well, how long are we going to have to wait until this car has a value of $12,450? What I'll do is I'll go ahead and hit my trace function here. And on the right side, you can see the value of the car at a given time. So 12,450, we're going to try to get as closely as we can to that value, 12,450. Here's 12,276, which is just below it. This is about 5.53 years. And if we go a little bit to the left here, we say 12,615. That's just a little bit bigger than 12,450. This is 5.32-ish. This is if we go back to the right, 5.53-ish. So 5.32, 5.53. It would have to be somewhere between this amount of time in years. And so if I had to guess, about 5.4, and I know I say 2 decimal places here, but that's if we were solving this algebraically. So we say the time is approximately about 5.4 years. Now what I'd like to do is the same thing again here, but with some different values, and see if we can't get you to figure this out. So pause the video, write a model for this, and use your calculators to come up with an answer to this question here. But when you're ready, go ahead and hit play. So hitting play now, we say that the value of the purchase of a new car of $15,600 decreases by 15% per year. So what we're going to do is write an exponential decay model for the car and then use it to determine the approximate number of years after which the car will be worth half of its purchase price. So again, we would say that in our model here, remember that our models are always y equals a, and in this case I'm going to go 1 minus r to the t. But in this case, our model, we say y, or f of x, is equal to our initial amount, which is $15,600, times 1 minus our rate, and our rate in this case is 15%. And so rewriting our model, I'm going to use f of x instead here, but we get this initial $15,600 that is decaying and becoming 85% of what it was every previous year. And so we say that this right here models this value over time. And if we want to look at, what this model's doing, let's just go and put this model into our calculator, 15,600, and our decay factor was 85% or 0.85. So because I have similar values in from our last example, we can see that this one's a little bit less down. We say it's starting off at 15,600, and over 20 years, it's decaying by, 15% a year. So going down a little bit faster than the value of our other car did. But at the same time, we're asking when will it be half of its original price. So I'm going to go ahead and hit second mode here, which just takes us to this word quit. And we're going to take half of 15,600 divided by 2, okay, 7,800. And what we're really going to do is we're going to ask, well, if the value were 7,800, then if we started at 15,600 with this kind of a decay factor, what would the time have been equal to? And so looking at this again here, we're going to get our calculator back out, go back to graph. I'm going to use my trace function here, and again, I'm going to try to get really close to a value of $7,800. So I suppose it would have been further back here, $7,800. Now, we're going to get as close as we can. We say 7,800, this is almost right on top of it. We would say that about 4.26 years. So I could say about, approximately 4.26, we're going to call this about 4.3 years. But this would be the approximate amount of time we'd have to wait by looking at that model there. Cheers.